Thank you all so much for coming today. So we have an exciting hour planned together, and just a note, we are leaving time for questions and answers at the end. So if a question pops in your mind while we're talking, if you want a clarification, please save it, and we'll definitely leave time for it. So just to set the stage for what we're going to talk through in our next hour together, we're going to talk through how you can utilize HPE's AI software stack to manage data pipelines and deployment in a very easy to deploy solution for Gen AI applications, So we're really going to talk through how you can take your organization's data, keep it safe, keep it private, make a data pipeline, send it through a RAG application, and deploy it with just a few clicks of a button. And we're going to end with a live demo showcasing how we do it. But first, I want to set the context for the world of AI that a lot of us are in today. So of course, AI, we're seeing rapid proliferation and adoption. In 2022, when ChatGPT was launched, I think the world changed for many of us. AI and machine learning went from a very targeted use case that enterprises were using for select solutions to something that was going to be part of our daily life in the office and at home. And there were sky-high expectations from many of our own leaders, and maybe even from ourselves, about what AI could solve, what it could replace, what it could automate. And the truth is, a lot of those expectations are aimed in the right direction. We've seen a lot of innovation already being driven from AI and a lot of different use cases, and we can see already how it's reshaping the workforce. But at the same time, we've also seen some of those challenges that have come up and really been a driving force in the AI conversation, especially in the last 6 or 9 months. And those are focused on 2 things in particular. The first one, part of every earnings call for any major corporation, I think, in the last 2 quarters, is the cost and complexity of AI. The hardware that's required to run AI is very costly, and the AI talent you have to hire to have advanced AI use cases is also expensive. And there's also, and I think this conversation is just getting started, but the ethics and regulation of how we govern AI is something that's going to continue to evolve. And so let's take these challenges in a broad sense and look at a specific example. So this is a real customer that we at HPE have helped across the last year. And let me set the stage for what this customer was going through. It's a police department in the United States, and they had a challenge that I think is as old as business itself, which is we have to write these data reports. If everyone has seen the movie Office Space, 1999, the TPS reports, this is something that is not anyone's favorite task, but is really crucial for both if you're a police department, legal reasons to sending the data to City Hall, but also is crucial for any business leader or department leader, public service leader in this case, to make decisions about where to staff their officers. And the police officers in this particular department were responsible for creating these reports. Now, of course, the problem is public budgets in many cities, at least in the US, around the world as well, have limited funding right now and strained funding. And so they want to maximize the time that their police officers are out either preventing crimes or solving crimes, not spent at their desk writing a report. And so they came to us and said, we have all these data sources already. We have call transcripts, we have incident reports, we have booking reports. All this data exists. Can we automate this reporting process to save our police officers all this time and put them to use on what we hire them to do and on what their skill set is? And we at HPE said, of course, we can help. And so the solution that fits this use case that is utilized and really blowing up across the generative AI space right now, you may have heard of it. I'm going to do a brief overview, but it's called Retrieval Augmented Generation. And so when ChatGPT first came out, just to set the stage for what each piece is for RAG, ChatGPT and a lot of the other models like it, like Meta's Llama, are large language models, and they're trained, of course, on a wide variety of public data that's available online and a lot of other sources. But all that data is public, and so they're very, very good at understanding, of course, the context of questions that we ask, and going through their vast training library and finding what the right answer is and putting it back into an answer to us in the classic chatbot use case. But of course, the challenge in this case is none of these models have been trained on the specific private data that an enterprise or an organization like a police department has. And for obvious reasons, the police department cannot make that data public. It needs to stay very safely kind of behind their firewall and very secure. And so what RAG does is it takes these existing large language models and it merely connects it to a knowledge base made up of kind of your organizations, your enterprises, in this case the police department's own set of data. And so by doing that, you don't have to retrain or fine-tune the large language model to get the result you need. You just need to give it the context to pull from so it can provide an accurate response with the way it's already been trained. And so again, there's just two pieces here that we really need to solve for. And of course, there's more complexity that we'll go through in a little bit, but the main two pieces are we have to find a way to build this knowledge base, and then we have to connect it to the LLM and make a working pipeline and like a working RAG version for the, in this case, the crime analyst or the police officer to utilize to ask questions or write their report. And so, yes, it seems simple, but of course, as with any solution, there are definitely challenges. And we think of the challenges in two different contexts. On the one side, you have the pressure that those of us in data science or those of us in the AI orgs are under from the business owners. And those are the speed to market. So the expectations, again, are sky high for AI. If we're given a problem today, we're not given 2 years to solve it, and we need to solve it yesterday. There's the cost efficiency. The cost of AI is something that's top of mind for anyone. There's the quality of the final application. We can't have a RAG application or a generative AI application that's giving irrelevant or false answers if it's hallucinating, and it needs to fall in line with our enterprise's own organization control and compliance. And with a lot of the solutions that are out in the market today, I think it's very easy to hit one or maybe two of these buckets. But it's very hard to hit all four. So to give an example of this police department, theoretically, you could share your data with OpenAI and use it with ChatGPT, and you would probably get a relatively high-quality version of what they were looking for. But the key problem is this does not fit two of these buckets. One is you'd be paying OpenAI quite a bit for every token utilized in this entire process. And the second thing is, of course, this organization cannot make their data available to OpenAI. And so the solution we're going to propose today and share with you fit all four of these buckets for the business owner's end. And then, of course, there's also the end user of the software they're designing, the data scientist. And so the data scientist has two sets of challenges, is how we bucketed them, if a data scientist is tasked with developing a RAG application by themselves. So first, let's think about the data side, the data preparation. Unfortunately, with RAG and with large language models, you never get away from like the time-old problem of time-consuming data cleaning. I used to be a data scientist a decade ago. All the way back with random forests, through deep learning neural networks, you always had to spend a lot of time cleaning data and processing it so it's in a state that your machine learning model, or in this case, your large language model, can process. And so that just takes time. And it's not the most fun work, and it's very manual. And then, of course, we also have to set up pipelines so that if we receive new data, if a new, in this case, police report or incident report comes in, if we're in production, how do we manage versions of that knowledge base? How do we get that new document into the knowledge base in an easy and automated fashion? So that's just on the knowledge base creation side. And then, of course, we have to take this whole RAG version and put it into production. And so on the production side, production is very compute intensive. This is where the costs of AI are really hitting organizations, at least on the software side today. If you're getting, in this case, you might have just a few police officers using this solution. But if you have a chatbot that's available for hundreds, thousands of users, all of your customers, your inference costs are going to quickly grow. And so you need to make sure that you're optimizing each GPU that you've purchased. And you also need to make sure that your solution can scale as more and more users come in a natural way that also is cost efficient for your organization as a whole. There's also just a high risk for errors and bias in production. You need to be monitoring the model. You need to make sure it's working as expected. And you need to be able to catch it if it's sending out false information or not performing as you see fit in order to stay in compliant with your enterprise's own rules, regulations, or just for your own reputation. And this work is quite different than what a data scientist typically does. And so our goal when we're making this solution is to not have an enterprise have to hire a data scientist team to develop the RAG application and a completely separate team just to handle deployment and monitoring. We want to take care of this under the hood. And so we have developed, I just want to set this in the context of maybe some other software solutions you've heard of over the last 2 days. So we've developed a solution, we're about to get to it, but just to put this in context, this orange box on the slide in front of you, AI software is where we sit and where these solutions sit within HPE and NVIDIA today. And this is part of the larger private cloud AI experience that HPE has developed with NVIDIA that of course has hardware, it has software, it has services on top of it as well. But we're going to be talking specifically about the software that we've developed in collaboration with NVIDIA. And so to discuss more about what the actual solution is to the problems that I've set up, the first intro to this presentation, I want to invite our Chief Data Scientist, Jimmy Whitaker, to the stage.
All right, thank you, Derek.
Yeah.
We might have lost some of the slides.
No, we're
there
good.
we go. Okay, perfect. There we go. That's my bad. Yeah, thanks. So there's a few different pieces that you've talked about,
Yep.
and I know there's a lot to go into. We're going to get to a demo here in a second. Did you want to maybe give a little bit of an overview of this, or a summary, I guess, a little bit of kind of this RAG knowledge base data management piece, and then also some of the RAG production stuff?
Definitely. So we split this into 2 buckets again, the knowledge base side and the production side. But there's a few key capabilities as Jimmy walks through what our technical solution is from the software that I just wanted to highlight and have us pay attention to. So the one is we want to be able to connect directly to your data source. We want to make this as easy as possible. And we want to have an automated way to update your data source whenever a new document or a new piece of data enters that knowledge base. And then, of course, if you're in the process of updating, you need to be able to manage versions and create production-ready data pipelines. So that's like part one of like the key capabilities that we're going to demonstrate next. And then on the production side, I've already alluded to this, but of course, our software solution for inference can deploy a wide range of large language models via NVIDIA's NGC catalog. So you can use multiple versions of the Llama model to fit your own preferences, like the size of the hardware that you have and your use case. And we also have built-in optimization to take advantage of those GPUs provided by NVIDIA's NIM solution. We also auto-scale in real time. We take care of that under the hood, so your team does not have to worry about it. And we offer, as I've already mentioned, real-time monitoring for your own control and compliance reasons. Yeah, so Jimmy, why don't you take it away and show everyone what we've developed.
Excellent. Thank you, Derek. All right, so yes, I mean, Derek's given us a pretty weighty overview of a lot of these things, so we're just going to jump right in. So the 2 pieces that we kind of talked about are up here, the knowledge base and then the RAG production components. And what this really breaks down to is there are the pipelines components, which are in kind of the title of the talk, where we're really managing how we're ingesting this data, how we're curating things, to create this knowledge base. And then on the other side, we have the RAG production, and this is a lot more centered around how we're deploying something, how we're going to create our inference services and everything like that. So let's first talk about just this pipeline process. So there's a variety of pipelining tools out there, tools like Pachyderm or MLflow or Kubeflow. There's a lot of different things that are, for instance, available in PCAI and other kinds of things. So the workflow that I'm going to talk about is going to be pretty general and can work with a lot of different pipelining tools. But the main goal of pipelines really are that you're wanting to figure out ways to automate some of this data processing in a scalable, flexible, and maintainable way. So those are kind of the key components. Because essentially, our data is going to continually grow. It's always going to be changing a little bit. We're going to need to keep track records of how everything's changing over time. We want these things to be automated so we don't have to run scripts every time something changes, so on and so forth. And then we also just want to make sure that we're providing a way to iterate on some of these things. We're never going to get our data processing right the very first time, and everything's going to work perfect. So we need to be able to update these pipelines, change things, and just overall be able to move with the times as we're getting more data and feeding it back in from our overall process. Overall, the development of these, of all of our applications is going to be iterative in some way, shape, or form. So the pipeline tool that we're going to be looking at in the demo here in a little bit is going to be using Pachyderm, but again, this will work for many different types of tools. So on the inference side, many of you have probably heard about NIMs. If you haven't, I'm going to give a brief overview here. So NIMs are an NVIDIA product that has been released that are essentially NVIDIA inference microservices. Now, these inference microservices really package up a lot of the great things that NVIDIA is doing on kind of the lower level optimization of large language models. So for example, TensorRT or TRT-LLM and a lot of the lower level CUDA optimizations that have happened for large language models are packaged up in here. And essentially what they've done is they've wrapped this up into the standard APIs that you're familiar with if you've worked with, say, something like OpenAI and that API spec where you're calling the completions endpoint. It looks exactly like that, but it's inside of this microservice that's optimized to work with NVIDIA's hardware. And this is great because no one knows how to optimize things for NVIDIA hardware like NVIDIA, and so it's nice that they have this, this inference microservice that's made to perform optimally with the various models that are introduced. And even more conveniently, this runs on top of Kubernetes. So what we have at HPE, or what we've developed, is this machine learning inference software. And so this is a project that I've worked on for quite a long time, but we basically wanted to say, NVIDIA is fantastic at writing these optimizations and packaging these things up to run on top of Kubernetes and take advantage of the hardware, but we wanted it to make it a little bit more simple for the developers so that you didn't have to know a deep level of Kubernetes for this, and so that you could connect to many of the different things that you would need for an enterprise-ready inference software, and make it available in a developer-friendly way as well as a manageable way for infrastructure admins and those types of things. So overall here, we can see that our machine learning inference software includes a variety of things. So we can work with NVIDIA NIMs. There's also a variety of other models and formats and custom tools that can also be deployed. For instance, we'll see here in a second that we can also deploy our RAG services that are interacting with our NIMs in there. We're taking advantage of those optimizations. And then we also have the ability to have our metrics and logging and security all built into the system so that when I deploy a model, I can be confident about how it can be used, that it's only available internal to my system, or I can make it publicly available however I want to do that. And also have the scheduling and routing that's available to do replicas of that model, do the canary rollouts, and all kinds of other things. So a little bit of a summary of how this works together. So we're, at least in the machine learning inference software, we're taking the NIMs, which are, again, just like very optimized microservices to run these LLMs. And then we're adding on kind of this serving and scheduling and routing capabilities along with all the metrics and other types of functionality inside of MLIS. And underneath the hood, we're using Kserve and Kubernetes, and this is all deployed with Helm. And so ultimately, we're really just trying, I won't read all the things here, but we're trying to get to this experience where there's this kind of NVIDIA and HPE better together story. So we're getting the best thing from NVIDIA, which is these pre-built containers that are going to make our inference really, really cost effective and optimized for the hardware that we have. And then we're also going to have the machine learning inference software that's ready to be to run on-prem, be optimized for your workload, and all the capabilities that you would need for an enterprise system there. So with that, we're going to move on to a demo. All right, so let's take a look. So the thing that I'm showing right here, this is just kind of an overview slide of how we're going to organize some things, and or just kind of a mental model. I do best when I have some pictures to kind of just give me a frame of reference of how things are connected. So we talked a little bit about what these data processing pipelines are going to do. Here we can see that there's this ingestion portion, and this is where we're going to take our domain data. We're going to pre-process it and basically create a knowledge base by running this through an embedding model, and then it ends up in a vector database. Then when we get to the deployment perspective, or the inferencing component, then we have essentially 4 things that are operating inside of the inference land. We have our embedding model that's going to be an NVIDIA NIM that's running. We have our LLM that's going to be able to do our kind of reprocessing of the data that's going to come back from our vector database. We have the vector database itself, which we've already populated with our domain data. And then we have this inference service that is basically interacting with our user. It's taking the query, it's doing all the things that it needs to do to get back our domain-specific documents, using an LLM to format that, to answer the question with those documents, and then return a result to the user. So first, let's look at the ingestion process. So again, this is a pipelining tool that I'm using here called Pachyderm. And essentially, like one of the interesting things here, you'll see quite a bit on your screen, but there's really 2 things that are happening. I have this pre-process pipeline that's running here, and then I have my vector database ingestion pipeline. So overall, this is pretty simple. And then I have, well, I guess I should also call out these data repositories that are providing the inputs to these pipelines. Some of these components are really just if I inspect this one, for example, this is the code that's going to be running to actually do the pre-processing, for example. Or I can see in my HR chatbot data that this is where I am putting the data from, or my own personal, or my own domain-specific data that's from my use case. Oh, one thing I didn't mention, sorry. We're going to be walking through, because the police data isn't readily available, that's all very private, we're going to be going through an HR example. So this is going to be a very simple HR chatbot that we're going to use our own specific, not HPE, but a specific HR set of policies, and we're going to be asking questions about that. Sorry, I probably should have noted that we were going to talk about a slightly different use case from the one that's very private to a customer. So in this we can see I have this HR handbook, and I can look through the different details about this, which doesn't appear to be loading, but it's there, I promise. And so I have all this data that's here, and what we can see is if I have the data and the code that's going to be running, so if I want to modify that code, then all of these things can flow down from there. And what we're going to end up doing here is I'm just going to show you if I upload an additional file, then we should pretty quickly see that some pipelines are running. You can maybe see some of these lines that are moving across the screen, but that's showing that our pipeline is running here. And so if I look in this job, I can see that there's a lot of different details that are going on here, but ultimately it is flowing through, our data's coming in, it's been pre-processed, and now it's going into the vector database ingestion so that it can populate our vector database. And we can see that that succeeded. So now our vector database should have the information of the PTO policy that we just uploaded. So now I'm going to move over to MLIS. So we've ingested our data. Again, just to go back to this, we've kind of gone through this ingestion process, and we've ingested our data into this vector database. And so now we're ready to interact with it. So I've already deployed my RAG pipeline. And then I have these two other models here, this one being the embedding model, which is using a NIM, and then this one, which is our large language model, which is also using a NIM. And so essentially how MLIS works, how makes it a lot easier, is that we have these registries. And so this registry I can connect to, in this case, my NIM registry. So this has the information, my API key for connecting to NGC. And then I can create these packaged models. So for example, if I was going to create a Llama 3 model, then I can type that in and then select my NIM registry, and this will automatically populate all the different models that are available from NIM. I can then choose my, say my Llama 3 8 billion model. This populates the image, and then I can go on to defining the resources that I want to use for this model, and so on and so forth, and create that. I'm not going to do that now since I already have one. And then after I create that package model or connect that package model, then I can create a deployment. So here, I already have some deployments created, but basically I can select my packaged model. I can then select where I want this to deploy. So this can be like a Kubernetes namespace or wherever you have your GPUs allocated. And then I can move on to the scheduling. If you have some very specific node selector options, then there are capabilities there. And then finally, this is where we get to the scaling. So if I want to say scale from, I want a minimum of 1 node always available, but then I want to scale up to a maximum of 8 replicas of this service, then according to a concurrency rule or something like that, then I can do that. So if I'm getting beyond, say, 50 concurrent operations on a particular instance, then it's going to start scaling up replicas to handle that extra load. And all this happens automatically. You don't have to worry about any of it, and it's going to use that NIM across the board. And so we also have the ability to add some environment variables and other things. I won't go into all the details here. We're going to be at we're at a booth 405. So if you want to see more details about MLIS specifically, then definitely check that one out. So overall, the exciting thing is we have all the components. Our vector database isn't shown here, but it's also a component that's deployed. But we have our RAG pipeline, we have our Llama model that's running, and then we also have our embedding model. Now, when we combine all of these together, now we can put in our user query and get back our results. So here I'm going to use the Open Web UI, and I'm going to connect both my Llama 3.1 model and also my test pipeline, which is my RAG pipeline, and ask it what's my PTO policy. So when I run this, I can see that, at least on the Llama 3 side, that might be a little bit small, I'm not quite sure. But on the Llama 3 side, or 3.1 side, we can see I'm a large language model. I don't actually have any access to your PTO policy. But then when we're looking at our RAG pipeline, we can see the exact answer from the handbook that we uploaded here. And we can kind of compare between those two. And so this is really exciting because we can see how we started with data, we uploaded some specific data about our HR policies, it went through and ingested it into our knowledge base in an automated way, and if I add more data, it's going to automatically ingest into the knowledge base and rebuild that index. We saw how MLIS can be really, really simple for deploying these models and interacting with these systems. And then we can interact with all these things. And this ultimately what's being served by these services inside of MLIS are those standard OpenAI API calls, so you can integrate this into pretty much any tool. It doesn't necessarily have to be a specific tool like this Open Web UI, but many other things there. Yeah, so I think that's about it for the demo. So at this point, I want to invite Derek to come back up. And basically, we're going to talk about what we kind of saw in this demo right here is how we've decided to optimize some of the processes of ingesting data and deploying some of these models and just making it really kind of streamlined for how to get to like an application that's enterprise ready, that's able to run inside your firewall with the security and the scale that you would want for an application that you're building. But then also we realized a lot of these things could be much more made more user-friendly, I guess. And so we're constantly trying to push the envelope of what's simple to use and how we can make things more simple and more powerful for other people. So I'll hand this over to you to go through some of the next parts.
Yeah, thank you, Jimmy. So what we've prepared today is a brief demo video of the next stage of this product that we're hoping to launch in the coming year. And so what we're really focused on, as Jimmy said, is how can we democratize AI? Like, as there's an ever-growing list of AI use cases, as there's still like a very limited bucket of AI talent, how can we make these tools easier to use, more integrated, and more iterative, so you can produce and improve upon your RAG applications or any other machine learning application, for that matter, like in a very easy format. And so we'll move ahead with the video. One thing to note, we are using the same example that Jimmy walked through in the demo for this video of the HR chatbot is the example. So here we go. So in this demo, we're going to start again with a list of projects. So you can separate, of course, your users into your projects, your data, based on your enterprise's own needs. And we're going to start with the HR chatbot project. And we're going to land here on a playground where an end user can experiment with the model. We have a foundational model selected. We have no knowledge base yet. And we have a very simple system instruction of you are a helpful assistant. And you can see the answer is a little generic. And we wanted to give it, if the bot doesn't know, we want to kind of use some prompt engineering and have it say, no, you should like email HR if you don't know. But of course, the real way to improve this version of the chatbot is to actually add the specific knowledge it needs to give the accurate answer. So in this case, we're creating a collection of documents, and you will be able to drag and drop the documents, connect to a SharePoint file, like wherever your organization stores this data, we'll connect with, and then we'll move through a process to automatically remove PII from the data, clean it up and then chunk it. Chunk in this case is just separating your data into different chunks that's easy for the LLM to query through. And then now we're going to reconnect that knowledge base back to the Playground experience, and we'll be able to ask the same question again, but now the chatbot should be able to actually give us the specific answer of the PTO policy that's in the documents. And you can see here, I think the maximum is 240 hours. If we're happy with this version, we can save it. We can experiment with other parameters and save other versions. And then, of course, you always want to run some batch eval, compare your different versions. You can look at details for each response. And if you're happy with the version, you can deploy it. And this deployment experience is fairly similar to what Jimmy just showed, where, again, we're handling the optimization with NVIDIA NIMs. We're handling the scaling, the monitoring, et cetera, under the hood. So it's just an easy one-click experience. And so just, I guess, to summarize, that was a quick video, but I guess to summarize where we're headed again is that experience was integrated. You didn't have to switch between different screens. You didn't have to switch between different tools. And it's available within HPE software stack. And our goal is that you can utilize that GUI Even if you don't have a ton of AI knowledge, you can upskill yourself, and you can produce and iterate on a production-ready, like RAG version or an agent for whatever use case like your organization sees fit to deploy. That's where we're headed. So thank you all again for listening to us for the last 35 or so minutes. And we are definitely happy to turn it over to some Q&A if anyone has any questions. And one last note, Jimmy already mentioned it, but if you have more questions, especially about the inference products that we showcased today, we are at booth 405 upstairs.
And we can show you the videos in a slowed down way. Or
Yeah,
go into more
show it in more detail.
Yeah. So we blazed through that one, I think.
We did,
yeah,
and there's a microphone over here that we'd ask everyone to speak to, so we can hear the questions.
For the question, I think there's one, maybe
there's
just
that one
here,
yeah.
If that's all right. Oh, we do have one.
There. Quick question. Given the exponential growth of generative AI, what do you see as the future for inference, and why is MLIS better than anything else that's out there?
Sure. So I will start. I think that in my own point of view, there's two trends within the world of AI that are going to be increasingly in conflict. So one of them is that the power of these large language models is going to grow, but that also means that the cost of training them and also putting them into production will also grow. And so you're going to need more GPUs to put these models in production, which is going to put a lot of pressure on exactly what AI use cases are being prioritized, and also how do you optimize those GPUs. The other trend that we're seeing, of course, is the proliferation of AI use cases. And so that means that there's more demand than there probably is talent for today, at least data science talent specifically, to create more AI use cases. And that's where I think what we showcase today, what our vision is trying to, with our software and with our partnership with NVIDIA, resolve the tension between those two trends, where in a cost-effective manner, you can utilize the most powerful large language models on the market today for your own applications, and you can have staff that maybe is not the best AI talent, is learning AI still, and they can, as long as they know the basics, they can walk through these tools and utilize them to still produce powerful AI agents. So that's, for example, like what we just saw in the demo today. We utilized NVIDIA NIMs under the hood for that GPU optimization, make sure we're getting the best bang for the buck for each GPU that we're using to run this HR chatbot, or in the real world case, this kind of crime report chatbot that we built. And then on the same end, we are building HPE software on top of that that's making it simple to use, easy to walk through the process, and easy to iterate and manage your versions for both audit and compliance reasons, and also just for the sake of reproducibility within your own teams of whether it be data scientists or just subject matter experts that are trying to make a chatbot or an AI agent for their own use case. So I think that's the future of inference. It's like the first question, like where we're headed. And then I think for MLIS, with where it stands in the market today, and Jimmy, please feel free to add to this, because I know you also know the market quite well. But there's kind of two sets of buckets of solutions for inference. One of them requires you to share your data either on the cloud or like with another company. It has to be beyond your firewall. And that would be AWS Bedrock, kind of the enterprise suite from OpenAI, et cetera. And that just really doesn't work for a lot of enterprises that need to protect their data better and ensure that it's staying behind their firewall and you're in control of that security at all times. The second set of solutions is really focused on open source. And this is where maybe Kserve comes in. This is a good example where it can handle the scaling quite well. It can auto-scale for you. But to utilize Kserve, to utilize all of these open source solutions, you have to be highly technical. You have to be able to stitch it together with different pieces. So if you want to combine NIMs with Kserve, you have to hire a team to build and maintain that yourself, which is quite expensive. And sorry, I lost my train of thought there. But the open source solutions work, but they're focused on very specific use cases. And you're going to have to manage and maintain them yourselves with your own AI platform team. And so I think what makes MLIS unique is it's very flexible. It sits within our AI software stack with PCAI, but it also can connect not just to NVIDIA's NGC, but to any model you pull from Hugging Face. Like, it's a very simple click-through process of connecting to your model registry, selecting the model you want to deploy, selecting your resource and scaling templates, and deploying it. So you don't have to know Kubernetes. You don't have to manage that YAML file under the hood. We take care of that for you. And we didn't even showcase it today. We can showcase it upstairs if you come by our booth. But like, MLIS also will auto-create a monitoring dashboard for you in Grafana that you can edit. You can do drift detection, compare your what the input and output is in inference to whatever data utilized in training. If you're using like a more traditional use case, you can monitor the requests per second, see the usage, see the failures, download logs for audit purposes, et cetera. So Jimmy, I don't know, Jimmy, do you have anything to add to that?
It's pretty comprehensive.
Okay.
No, I'll add one thing. I would say, like, kind of in summary, I guess, the main thing that we really tried to design MLIS for was to basically give you the lower level power that you needed to be able to do some of these things, the scalability, all the things you would want from an enterprise software. But then we want it to be accessible. Like, we want it to be developer friendly. Like, when we were designing and building this, I myself was focusing on, is this something that I would want to use consistently? And that's I think we've struck a good balance there, if I'm honest. I enjoy using it. It does what I need it to do. And it's also flexible. So for instance, that the non-NIM thing that I had deployed, like the pipeline or the RAG pipeline itself, I had to write the Python code, write the code to actually wrap that up as a service. And then I can trust MLIS to scale that dynamically and do all the appropriate things, as well as add the authentication and security components on top of all of that. I'm not a Kubernetes expert. I'm very much in the realm of data science and machine learning engineer, but not more on the machine learning and less on the engineer side. So the fact that I was able to do that with the software and pretty easily incorporate that, I think makes it really, well, personally, I could speak from experience in saying that's much easier than some of the other products I've used for those types of use cases.
Yeah, and maybe one other advantage to speak of that we didn't show today, but there also is a coding interface, right, Jimmy? The CLI.
Yeah. Oh, sorry. Yeah, that's a good point. So yeah, also all the things you saw, we saw the UI. Behind that, there's the API and like a CLI. So if you're wanting to automate some of these things or make calls to, for instance, I guess one of the pipelines I didn't discuss inside of there was my deployment pipeline, but that's making calls via Python to create the package model, to create the inference service, to create the deployment and everything and configure things in an automated way. So as you're starting to look towards automating the creation of the package models, the creation of these services, how they're connected together, any type of configuration or customization, then you can get to that coding level, and it's pretty seamless to be able to do those things.
Awesome. Thank you for the great question.
Yeah. Any other questions?
Do you mind going to the mic?
Yeah.
We're definitely happy to answer.
It's more for everyone else to be able to hear as well. So.
Yeah, no, so follow-up question. So you mentioned that you already have the monitoring and Grafana and you can show it upstairs. But then you also mentioned that you have drift detection already built in. So because the last 2 days we saw some of the live demos and stuff and they didn't show that stuff off. And
Yep.
It was quite nice to hear it now, but so it's already there?
Yeah, so what MLIS shares as a product, so drift detection, just for everyone in the room, is when you need to compare the training. You're obviously training and evaluating your model or your LLM on a set of data that's internal to your company. And then when you put the use case into production, you want to make sure that the data, or like in this case, the chatbot, the type of queries it's given, are matching what you trained it on and what you tested it on. And if it starts to drift, and like the model performance starts to drift, then you're going to have issues with the quality of the responses. In this case, like the HR chatbot or the crime chatbot. And so what we can offer for MLIS, we only see the inference side, of course. So we don't know the data that your enterprise used for training and eval. But what's available through the CLI is you can pull that data in a JSON format, and then in whatever tool you choose, or maybe as part of like other libraries within PCAI, you can create and monitor your own drift detection. So it does take a few extra clicks since we don't see the actual training eval data on your enterprise's side, but we can definitely make the data available via the CLI in the machine learning inference service product. Did that answer your question?
I'm not sure. So I have to build the extraction for the data and stuff and basically the drift detection myself, or you have it built into your product?
It's kind of a combination.
Yeah.
It's more, to be frank, it's more on you have to build some components yourself. Essentially what MLIS is doing is it's collecting, well, if you have it enabled, it's collecting the data from the inference requests and all of these types of things. You can export that, but basically it depends on how you want to compare that data. So for instance, with drift detection, if you're just doing more of a classification type problem, which is less generative in nature, or you're only generating certain outputs, then you can do, then it's quite easy to figure out if your classification errors in domain, out of domain, and all those types of things, and figure out drift detection on that front. But then if you have, essentially it's really hard to compare really long strings to really long strings and figure out if it's drifting or not. It's kind of an odd problem to solve a little bit, which maybe you're asking like, that's the situation and you want to know how to solve that problem.
No, that's
okay.
Because I know how complicated it is to solve.
Yes.
And it's basically, I was just thinking, yeah, okay, so we haven't seen it in the last 2 days, and now you mentioned it, and I was quite unsure. And you also said that this video is where you want to go, and I don't think that's exactly where you are as of right now. And that's why I was asking. Okay.
So I would say, maybe to even rephrase, so like drift detection is a thing that gets thrown around and it means a few different things. And it is a hard problem. To my knowledge, it's still very much an unsolved problem in a lot of areas. And there are ways to do it for a limited scope in generative AI, again, more with classification type scenarios. Yeah. But so I would say more of what we have is in the realm of like evaluation, like steps or stages where we can pull the data out and do evaluations. And there are ways to have some of those evaluations be drift detection type stages. But you're more reliant on like perplexity metrics and those types of things of seeing if something's more in domain or out of domain with comparison to those strings that are, or comparison to like what's generated versus what it was trained on and those types of things. But that is a little bit more of a manual process. It's not like click, 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 and then there it is at this stage right now. Yeah. We definitely want to make it that, but it's not there yet.
Okay, thank you.
Yeah, that's very fair. So there is more data that you can access with the CLI if you want to build some of these use cases within your own enterprise. It takes a few extra steps, but we do have the ability to make the data available, or like you do, and customize it for your use case. In this case, the data from inference, input, and output specifically is the only piece that we make available.
Yeah.
Yeah.
And even specifically in the video you showed, like where we're trying to go with that is there's that evaluation dashboard. And some of those things would be, okay, here's the domain data that or the domain questions that you have. Here's how in domain, out of domain some of the newer questions are. So some of those things can become a little bit easier as we iterate on that path towards having that kind of studio type interaction.
Yep. We started with inference, and we're trying to integrate further in the stack so we can do more of these use cases where we can see the data from each different piece and make it very easy to iterate and monitor. It's like the eventual vision.
Yeah. Cool. Any other questions? Excellent. Sorry to make you walk to the microphone, but it helps out.
Yes, so I have a question because let's say we create basic RAG using the system, and we are like not happy with the output. Do you have some, because I saw you have comparison with OpenWebUI of two pipelines that you use.
Yes.
But let's say I have quite big case and I want to compare, improve it. Let's say, do you have some system that guide me through improvement, or lets me have some history of request and monitor it?
Yes. So yeah, it's a great question. So basically, once you have the basic RAG, where do you go from there?
Yeah.
And how do you go forward from there? So on the at least in what we saw there, like all of those stages and steps are automated to a certain degree. I probably could have gone into a lot more detail on some of those components and what's going on behind the hood. But each of those pipelines is backed, or the code that we were showing, those are being pulled from notebooks. And so if you want to go kind of that next level deeper for, say, a machine learning engineer or something like that, then you can go into those notebooks and even just modify the code that's supplying the code for that pipeline. And that pipeline then scales out that code and parallelizes it and processes all your data. So great things there. But so essentially you can go into that code and like either add more data or change up the way that you're processing it, or even change the embedding method. So if you want to do some like a weighted hybrid search or something like that, then you're changing a few configuration options inside your vector database and how you're ingesting that data. So there's a variety of things that you can do as you're starting to go lower and lower level. The main thing is we don't want you to have to necessarily go to the Kubernetes level and have to change like manifests and values YAMLs and all of those types of things. And so then once you've configured all of that, then there's still some minor modifications you need to make to that OpenAI service, because say you're using Llama Index, you need to basically make sure that you know how to interact with that service. But it's all relatively minor, like data science-esque code that's going into this process to do that. And then where that ends up going with the AI Studio, again, very much a prototype of where we want to go next. The intention is very much to put in kind of the cutting edge functions in there that are proving to be most valuable. So weighted hybrid search being one of those, some standard evaluation metrics that are really powerful, and all of those things, so that we can find out before we've deployed anything how well our model is going to do on this selection of questions and answers and those types of things. And then the whole feedback loop, we want to export from MLIS back into our questions, and then be able to do probably some level of labeling to identify what needs to change, or this is a good answer, this is a bad answer, or now how are we doing on our test set, and that type of thing. So anyway, all that to say, that's a long and robust way of saying there are ways to go a little bit deeper, a little bit deeper, a little bit deeper, kind of at every step. Because we don't want it to just be, here's the click through, and then you can't do anything else except the very, very simple RAG. We want you to be able to go that next level deeper, but we don't want you to shoot yourself in the foot in the process as well.
Okay, I see. Thank you.
Thank you. All right. Anything else? Well, if there's no more questions, thank you again.
Yeah.
I don't know if you want to.
Yeah, thank you all. Your questions have been great. I think they're pointing in the direction of stuff we've thought of as why we want to develop this next stage of the product, that close some of these holes, make it more integrated across the entire lifecycle, and not just be focused on the data pipelines and the inference. Our emails are here if you would like to get in touch with us. We'll also be outside the room. We'll stay out for a few minutes in case there's any other questions. And you can always find our team at booth 405 upstairs. Yeah. But thank you so much for coming to Discover Barcelona. Thank you for coming to our talk in particular. We really enjoyed speaking with you all today and answering your questions. Yeah. Thank you.
Thank you so much.